Hi, welcome back to another shortish C# video. This time hopefully showing you the futility of using exceptions for flow control, which you inevitably end up doing when using try-catch blocks, unless you embrace other techniques. But at the end of the day, use what works best for you. I will go through a couple of examples, with our playground being quite realistic in that it's structured like a lot of applications minus the domain, as not to go too overboard. We have a console client that will call a web API or a gRPC service, which in turn will issue a command or query to be handled in the application layer using an injected read or write EF core DB context set up in the infrastructure project. The demo does not do much, but without all the pieces in place you cannot appreciate the decisions that need to be made from getting data out of a system and onto the user's screen. The demo has a small SQLite database that contains a couple of tables from the Northwind database, which we will use to both get a record out, ensuring everything is working, and then to have a foreign key constraint violation raised when we try and delete a supplier that has products in its related products table. If you download the source code, just remember to set multiple startup projects, server then client. I'll be using the IIS Express server for the demo. As you can see on the right hand side in the Solution Explorer, we have 5 separate projects: the client console, a web server for our API and gRPC services, our application project for command and queries, a contracts project for shared models and interfaces, and an infrastructure project for our concrete DB contexts. I am only using the single program file on the client side, but have added the Microsoft dependency injection package just to get hold of the HTTP client factory. I have added breakpoints at various places so we can see what's happening, and as we will be in debug mode, any errors will cause Visual Studio to stop on the offending line, after which we can continue on. Okay, let's begin. We will first make a request just to make sure everything is working by requesting a suppliers view, a small data object that has a couple of fields from the suppliers table and the count of their related products. We hit a breakpoint in the suppliers API controller, and for those who watched my last video, we are using the instruction dispatcher that we built in order to send a get suppliers query to its registered handler. We continue and hit the breakpoint within the get suppliers handler. The DB context injected into it is meant for data reads, not writes, with the select using a projection, an expression func added to the EF core suppliers entity, so we do not need any mappers. This DB context has lazy loading disabled, but we do not need to use the include for the products table, as our expression for the projection will output the correct SQL for it. We continue on and land back in the programs file. Let's check the console to see what was written out. It looks like the Exotic Liquids company has 3 products in the products table. Let's try and delete this supplier. We hit the breakpoint in the suppliers controller where we are about to send a delete suppliers command. Continuing, we hit the breakpoint in its registered handler. As a side note, as this method is a command and does not return any meaningful value, we use a unit type that I call none, as my dispatcher implementation requires all instructions to specify a type used in the return from handlers. I press continue and boom, the database is doing its job and has informed us that our delete command has caused a foreign key constraint violation, which makes sense given the supplier has 3 products in its related products table. We do not have any try-catch blocks here in the controller or in any middleware, so the client will receive an internal server error. Let's continue. As I used the JSON extensions for the delete, the exception will get caught in the HTTP request exception block, which will unwrap the status code. Let's see what it says. Yep, the typical 500 internal server error. At this point, most devs are correctly thinking we need to add some exception handling, the better ones realizing that a constraint violation is not actually exceptional, but you work with what you've got. Right, let's do a quick refactor and add a try-catch block at the source of the error, a good starting point. I have added a try-catch, and as we know this exception isn't really exceptional, we can advise the user to make sure the supplier doesn't have any products before trying again. The problem now is, how do we get this message to the user? Our journey of using try-catches for control flow begins. This method doesn't return a string that maybe we could use, so perhaps a custom database constraint exception that we can raise and then catch in the service. This seems like a reasonable approach. We add another try-catch in the delete supplier method. I am not going to discuss using exception middleware or controller base classes amongst other things, as it always ends the same: exceptions and translations of exceptions. As ASP.NET Core has built-in support for problem details, we decide to use that for our response. We catch our custom exception and populate the problem's details and return it. The status code was meant to be 409, which is in the source code, but it makes no difference. It's still an unsuccessful status code. As we are now using problem details, and as we may get other errors from the server, especially given the amount of methods that are typically added, we decide to centralize our error handling for our client's API calls by using a delegating handler, which all of our calls will get routed through. Code is added to check for bad status codes and proceeds to check if we have a problems details object that we can deserialize for inspection. Back in the programs file, we have now switched to use the delegating client that we get from the HTTP client factory. Our delegating handler was added to the service provider, which was configured to give us both clients with or without this handler. Let's run the app again and try and delete the supplier with our exception handling code now in place. We hit the breakpoint in the suppliers controller. Continuing on, we hit the breakpoint in the delete suppliers command handler. This time we catch the constraint error, populate our custom exception and throw it. As expected, our custom exception is caught in the controller, and we proceed to populate a problem details object that we can return to the client. Our delegating handler now inspects the status code, sees we have a problem details, deserializes it and writes the information to the console window. Let's see what it's written out. Sure enough, all the information is there. In reality, the details message may have been displayed to the user in a dialog before returning. We now face another problem. We have used a delegating handler to centralize handling, and as such could have numerous case blocks for different things, maybe capturing user input to decide how to proceed. But in these cases, how do we pass this information back to the originating method? There are things we could do, maybe set some sort of state variable, raise an event, or even add details to a custom exception and throw that for the originating method to inspect. No matter what you do, when you work with exceptions that are not actually exceptional cases, you will most likely have to jump through hoops or add more and more try-catch blocks. In my opinion, exceptional cases should just be left and allowed to bubble up to be caught and logged in a global handler. Anything else is a bug to be fixed or a failure that you know may occur, which again, in my opinion, can be handled gracefully without using try-catch blocks. Given it appears we are accustomed to using exceptions, we'll create a new client-side custom exception and throw it. Our custom exception is now caught in the originating method. At this point, I ask that you think about how you would have handled such situations. While you are thinking, I'm going to do another refactor, as I'm not happy about the try-catch in the handler. As how many handlers will we have? A small app can easily have 100 or more when you think about all the different views, adds, updates and deletes. I have now created a simple static error handler class, and just to keep things together, I have put it in our handlers file. It only has one method for the demo. In reality, it would contain a few more overloads. So what does it do? It just allows us to wrap a function call, passing in any exception handling function we like. So in this instance, In our delete supplier command handler, we will pass in a specific handler that knows about SQLite exceptions, but the handler could be for any type, perhaps one for file I/O exceptions, another for exceptions from a cloud service provider, etc. The operation will be attempted and the handler called if an exception occurs. We could use this technique to wrap any method, passing in our specific handlers. You can also do similar using an extension on a known type. Please note, despite popular beliefs, exception handling, in my opinion, should be used sparingly. However, they are a necessity at the edges where you contact external resources and services. I also created an interface IDB exception handler with a concrete implementation that is now injected into our handler. Let's take a quick look at it. The interface only requires a single method to be implemented, the handle method. You would add all the appropriate case statements for the exceptions that you expect to occur, not so exceptional exceptions. The handle to flow is not going to be covered here and is not part of the interface. I added this in order to return a value later in the demo instead of throwing an error like the handle method above it. Let's run the application again. We hit the breakpoint in the API controller. The breakpoint on the operation to try is first hit as it wraps the other code. Now the call to the database breakpoint is highlighted. I will continue for it to cause the exception. Boom! An exception is caught in our SQLite exception handler. Just like last time, we will use our custom database constraint exception and throw it to the caller so they know what's happened. Back in the API controller, we catch the specific exception, maybe adding more details using the extensions dictionary available on the ASP.NET Core problem detail and return it. The code goes through the same process as before, so let's whiz through it to see the console output. We are almost at the end of the demo, but I hope at this point I have provided you with some food for thought, maybe spurring you on to look at alternate ways of dealing with what was essentially a known issue. One alternative way is by using what is generally called a result type, a type that can have one of two values, a value for success or a value indicating an error, but not both, which will be the last demo in this video. The purest form of this is the either monad. I implemented one many years ago using abstract base classes, and it was about the best you would get in C# in terms of purity, but it was extremely verbose in declarations and almost impossible to serialize using gRPC or JSON, given the inheritance model that I wanted for failure types, so that version did not last long. Most developers use effective but simpler designs, and if you search on result type, railway programming or either monad, you will find videos and various examples. My latest result type is a simple generic class, Func T. I named it flow instead of result as I added support for being able to serialize various different built-in failure type classes using either JSON or code first gRPC, which is generally missing from examples that you may find, and I would surmise a stumbling block making it harder for developers to adopt. After using it for a few years to save copy and pasting between projects, I eventually created a NuGet package for it. Anyway, enough talk. Let's see what using a result type is like for getting the same supplier view followed by trying to delete the supplier. For this, we will again use our web API controller, but in addition, we will also make the same calls via a gRPC service hosted on the server. Let's take a quick look at the handlers and services before we run the code. For the getSupplier query handler, I added the exception handler using the flow return handler, as it's on the outer edge. It's a similar story for the delete suppliers command handler. It returns a flow with either a success or a failure, but no exceptions. If we look at the SQLite exception handler again, the flow exception handler does not throw any exceptions. It merely catches an exception and returns a failed flow. You can either create a flow or just use its implicit operators. Our exception handling process starts and ends here at the edges, generally contacting external dependencies involving I/O. Moving on to the API controller service. In this instance, the get and delete methods just send instructions and return the response. That's it. Obviously, other methods may require additional work, and Flow has extension methods to chain work together, taking into account success and failures, as I am sure other result types will also have. Last, we have the gRPC supplier service. As I like to use request and response message envelopes for gRPC, the get supplier just uses a return as extension to put the success result, a supplier view object, into a get supplier response, which is inside a flow. The service signature is a task of flow of get supplier response. The delete supplier just sends a command and returns a task of flow of none, which, as we know, should contain a failure, not a success, with no exception being thrown. Back in the program file, I have commented out the other code so we can just run the flow returning code. I have used Flow's extension methods such as onSuccess and onFailure to add calls to both sync and async versions of the console writeLine method so we can view the results. As we have seen the code and knowing that our code is not raising exceptions, only capturing a known database constraint violation, let's run without debugging, just inspecting what gets output for these 4 calls. We got what we expected, 2 success results and 2 failure results, and I hope you would agree that handling the constraint violation with a result type was simpler and more succinct than going the try-catch route. There's a lot more I'd like to share in using result types, whether that's just using them in your day-to-day development tasks or more about the design. If anyone makes it this far in the video, leave a comment if you're interested. I use my own result type NuGet package Flow in this demo, which also has its own set of demos, walkthroughs for those interested. I have put the link to the repository in the video description below. Before I go, I should point out that these days I mainly use Microsoft Tech on the front and back ends, and generally I have control over the clients and servers, meaning it's much easier for me to use a result type from the back end, seamlessly flowing it down to the client. A result type with code first gRPC is a great combo for Blazor apps. Anyway, thanks for watching, and as always, feel free to leave good or bad comments and I will try to answer any questions raised. All the source code is freely available to download. The links are in the video description below. Until next time, bye for now.